Hello, today I'd like to introduce a tool that I have been working on called Compenshell Studio. It is designed to solve one of the major challenges that you have with metal additive manufacturing, that being shrinkage of parts and compensating for that shrinkage. First, I'd like to just introduce what I want to achieve here, which is a simple and intuitive way for bringing in parts, accounting for the shrinkage, and ultimately getting your compensated part, which you can then send off to a slicer and print and hopefully get your dimensionally accurate results. For those familiar with my channel, you'll know that I primarily work with the Virtual Foundry filament. While that is my focus, this tool is not completely isolated to that environment, but it is heavily focused towards that workflow. The high-level overview for that process is A, you will print your part in whatever material that you want, copper, steel, whatever it is, and it's going to be printed on a regular 3D printer. From there, you will take it, and it is still bound with a binder. You can consider that maybe PLA or some other mystery glue. That needs to be burned away thermally, so that's where you take your part B and put it into a crucible. That crucible is going to be filled with a ballast, which is just a powder, normally Al2O3, and you support that part within that ballast. C, you will take it, put it into a kiln, burn away that binder, and you are left with a brown part. Now D, that is with your brown part. This could be part of C, just depending on how you do your kiln cycles, but that is the sinter phase. And sinter, S-I-N-T-E-R, that is where you reach very, very close to the melting temperature of the material that you have, just not quite past it. And it fuses those particles together and binds them further, and you ultimately end up with a relatively dense part, tunable of course, 70, 80, 95% dense metal or ceramic part. But that comes at a cost. It shrinks during this process. And that is a big problem if you're trying to find or end up with a dimensionally accurate component. Now, with all that being said, that is a process that you absolutely can figure out yourself. I've done this for many years, and it's been a lot of fun. It's really cool to just be able to go out and take something that you have in your head and prototype it and end up with this metal component. But like I said, that shrinkage is an issue if you are trying to end up with that dimensionally accurate part. And Compenshell is my solution, or a work in progress solution, to try to solve that for you before you have to go through the many years and trial and errors that I have gone through to figure that out. My goal and what I have baked into Compenshell is to be able to simulate against actual hardware that you have, actual material definitions that are published, while maintaining your freedom to edit those, and be able to, again, do this in a matter of seconds with a sort of digital twin environment rather than a 24-hour cycle is a huge win, at least from my point of view. Highlighting what you're seeing here, you can see that with this export of the simulation, we actually are, running through a full kiln cycle, including a debind and multiple step process. And in real time, we can kind of witness what the expected simulation says the shrinkage will be in not just a linear way. This is, anisotropic physics-based simulation here. And you can see this here with with some of the the movement vectors here from the before and after. But what's nice is that not only can you see the before and after, what you get is a full sort of report view and a results view that you can kind of walk through and just get a high level assessment of what should happen, or what we think is going to happen, and compare that with your actual results, and possibly save many days, if not weeks, of effort. At least that's my goal. And while this is not a product release or anything, this is not an open demo. I wanted to show what I have. I've been in tool building mode, which I've shared on various forums for a while now. Been focused a lot on microwave sintering. This is definitely going to make its way into that project as well. This is all kind of wrapped up in the same same work that I've been working on for a long time. But what I can say is, if you are interested, just take a look at the link in the description, or go visit compenshell.com. I am just looking for people who are interested, willing to help.